Hello students, in this lecture video I'm going to solve the numericals on problems on what fins. Okay, so after studying that fin introduction, okay, today I'm going to solve some numerical problems on fin. Okay, so I already told you fin nothing but what fin nothing but what it is an extended area in a given element, okay, by which we can increase the rate of heat transfer from one system to another system, okay, that particular surrounding area. Okay, so from the environment, from the environmental, by increasing the convection. Okay, so that is called as fin. Okay, just to understand that fin nothing but what it is an extended part. Okay, so I already told you about the fin, okay, in the introduction class. Okay, today I'm going to solve some numerical problems on fin element. Okay, so I told before solving the fin or any type of the problems in FEM, you have to make a list of formulae. Okay, you have to remember the list of formulae, then you can solve the numerical problems. Okay, so here question is given. Okay, so now this is a question. Okay, so this is also very important problem from the UT University. Okay, so now I will read the question here. So problem number one from problems on fin. Okay, so find the temperature distribution. Okay, so your temperature distribution in the one dimensional fin as shown in the below figure. Okay, so take it to two elements from the finite element idealization. Okay, so look at this, they are telling that there is a two element. Okay, let us consider this is a 2D element. Okay, so here this is a one dimensional fin element. Okay, so they are also telling that consider it as a 2D element. Okay, so this is a figure they given in the question. Okay, so here this side, that is a surface temperature is given 140 degrees centigrade, that is 140 degrees centigrade, and this T infinity is nothing but the ambient temperature, that is 40 degree, they are given 40 degrees centigrade. Okay, so length of this given element is, that is 5 centimeter. Okay, the diameter of the radius of this fin is 1 centimeter. Okay, so here K stands for what? Here the thermal, that is what, thermal conductivity, and H stands for the convection. Okay, so for you convection H is equal to 5 Weber per centimeter square Kelvin, and thermal conductivity is equal to 70 watt per centimeter Kelvin. Okay, so this is a given data they are given. So they are telling that to consider it as a 2D element. Okay, so here it is similar to the previous problem only, up to equilibrium condition what we solved in the previous model problem. Okay, but here they given what the boundary condition. Okay, look at this, this is a T1. Okay, so T1 is given already, this is T1, that is what specific temperature, or we are going to call as also a surface temperature. Okay, so T1, okay, the first step is you note down the given data and convert into the one unit, that is standard unit. Okay, find the temperature distribution in the 1D fin element. Okay, so how much temperature going to distribute in this fin element, that you need to calculate. That means what, you need to calculate the T1 and T2. Okay, T1 already they are given. Okay, T1 is equal to 140 degrees centigrade, we need to calculate the T2 at this point, and the T3. Okay, they are telling that consider 2D element. Okay, that I will tell in the next slide. Okay, so first step is you have to remember the formulas. Here they given surface temperature. Okay, they are also given the heat due to convection, and consider it as a 2D element. Okay, so note down the first list the, that is what, the write on the given data. So specific temperature, this side is the given T1 is equal to 140 degrees centigrade, you have to convert that into Kelvin. Okay, so degree centigrade into Kelvin means you have to add 273. Okay, so 140 plus 273 is equal to 413 Kelvin. Okay, so length of the given fin is given, they are telling the 2D element. Okay, so just if you divide exactly middle, so the length of the total length is 5 centimeter. So if you half of that means divide by 2, so 2.5 centimeter. Okay, that is consider L1 and L2. Okay, length is equal to 5 centimeter total, and L1 and L2 which is equal to 2.5 centimeter. Okay, so surrounding temperature, that is ambient temperature. Okay, around the fin, the temperature flowing around the fin is they given, that is 40 degrees centigrade. Okay, again this is in centigrade, you have to convert that into Kelvin. That is if we add the 273, okay, 40 plus 273, that gives the 313 Kelvin. Okay, thermal conductivity they are given, what thermal conductivity nothing but K is equal to 70 watt per centimeter Kelvin. Okay, convection heat transfer coefficient, okay, from one system to another system they are given what, so H is equal to 5 watt per centimeter square Kelvin. Okay, so radius they given 1 centimeter. Okay, so if you want to find, we need require what diameter of, that is what area of this. Okay, area of this fin. Okay, so we have the area formula pi r square. Okay, radius is given, so substitute here, pi value is 3.142. Okay, r square. Okay, r square if you substitute a 1. Okay, so 3.14 into 1 same as usual. Okay, that is 3.14 centimeter square. This is 2 is it, centimeter square. Okay, so perimeter again, that perimeter okay, the half of this nothing but what, 2 pi r. Okay, substitute all the 2 pi R value, so you are going to get 6.82 centimeter. Okay, so all note down the given data from the given okay, in the given question. Okay, list the given data. Okay, so they are telling the 2D element. Okay, so again step by step you are going to solve now. Okay, the first step is what? We have to build the FEA model. Okay, so this is a given diagram. Okay, comparing the given diagram, you have to they are telling consider a 2D element. Look at this. Okay, take it as a 2D element, finite element idealization, that is finite element model. Okay, so exactly if you cut the section here middle, okay, half of this, okay, so that you have to convert the given diagram into FEA model. Okay, look at this. So this is T1, T2, this is T3. Okay, so T1 to T1, that is element number 1, T2 to T3 is element number 2. Okay, so at node number 2 the L1 and L2. Okay, so this is node number 1, this is node number 2, this is node number 3. So number of nodes is equal to 3 here, and number of element is equal to 2 here. Okay, so nodes are different, elements are different. Okay, so node number 1, 2, 3. Okay, so T1 is given, you need to find out the T2 and T3 value. Okay, how the temperature distribution takes place in the given inside the fin. Okay, that you need to calculate here. Okay, so first step is we completed. Okay, that is comparing the given diagram. So given condition, condition from the given problem, you have to divide that into 2 element and show all the element here. Okay, so here T1, T2, T3 are the nodal temperature, that you have to remember. Okay, so how we solve the stiffness matrix for 1D bar element, element stiffness matrix for truss element and beam element. Similarly, that stiffness matrix for the heat conduction formula we have KC is equal to, okay, the before this, okay, the stiffness matrix is given by heat due to conduction plus heat due to convection. Okay, if you add those, we are going to get the stiffness matrix. Okay, so his stiffness matrix for the heat conduction, okay, conduction is given by, this is the formula we have. Okay, sometime the area is not given in the problem. Okay, so that time you have to understand that you have to assume the area is equal to 1. Okay, if they given, it is well and good. Suppose if it is not given, means you can assume the area is equal to 1 in the heat transfer problem. Okay, so Kc, heat due to conduction, is equal to AK by Le 1 minus 1 minus 1 1. Okay, already we derived this equation in the introduction class. Okay, that is the second lecture video. Okay, so here Kc is equal to, A stands for area, K stands for thermal conductivity, L stands for the length of an element. Okay, 1 minus 1 1. Okay, so now you are going to consider an element number 1. Okay, for element number 1, K is equal to, substitute here value. Okay, area we know, area is equal to 3.142. K nothing but thermal conductivity, that is the given thermal conductivity for the both the element. Let us consider this both the element K1 and K2 70. Okay, A 70, length for the first element 2.5. Okay, so now you substitute all the values, that is 1 minus 1. So you are going to get the heat due to conduction is equal to, if you simplify this, you are going to get 87.921 minus 1 minus 1 1. Okay, like that you have to calculate the similar to the second element. Okay, how you calculate the conduction due to first element, calculate the conduction due to second element. Okay, so again you substitute the same values here, 3.142 into 70, 2.51 minus 1. Okay, if you simplify, means you are going to get 87.92 1 minus 1 minus 1. Okay, so this is belongs to the element number 1, this is belongs to the element number 2 due to the conduction. Okay, not convection. Okay, so now you can add K1 plus K2. Okay, so thus the K1 plus K2 is equal to, that is global stiffness matrix for heat due to conduction is equal to K1 plus K2. Okay, I already told you how to add this. Okay, so depending upon no number. Okay, so this is suppose if you understand, if you look at here, this is a 1, this is 2. Okay, so this is from node number 2, node number 3, nothing but. So here in the next slide, okay, this is the node number. Okay, so this is 1, this is 2, this is 1, this is 2. Okay, so now according to the node number how we added, okay, like that you have to add K1 plus K2. Okay, 1 1 2 2, like that you have to add. Okay, same here also. Okay, look at this, this is node number 1 2 3 1 2 3. Okay, according to the node number you can add the K1 plus K2, so you will get this matrix. Okay, so similar same process is there according to that node number. If you add that K1 1 1, okay, so this 1 1 2 2, so you are going to get this matrix. Okay, this is due to conduction. Okay, 87.92 minus 87.92 0 minus 87.92 175. So this I am going to wrote from this point, that is with this matrix. Okay, this is 1 2 1 2, so 1 1. Okay, so if you multiply this 87.92 inside, okay, you are going to get 87.92 minus 87.92 minus 87.92 87.92. Okay, so similarly you are going to get both, you add, so which gives what here 3 into 3 matrix is maximum temperature in the given problem is node number 3 is there, so 3 into 3 matrix which gives this. Okay, Kc. Okay, Now this is Kc, heat due to conduction, okay, but we want what, global stiffness matrix is equal to what, Kc plus Kh, okay. How we calculated this? Similarly you have to calculate stiffness matrix for convection, okay. So we have the convection formula, Kh is equal to Hpl by 62112, okay. So this is the formula due to convection, okay. Substitute K for the first element, okay. For the first element Kh1 is equal to 5 into P is given what, perimeter, perimeter how much, 6.28 is there, so substitute here 6.28, okay, in this, okay. 6.28, length is given 6 is there, 2112, okay. Substitute in this element, you are going to get this matrix, that is for the first element. So Kh1 is equal to 13.083, this matrix, okay. Similarly you calculate the Kh2, okay, 13.083, okay. So now you combine heat due to convection is equal to what, Kh is equal to this into this. So if you add these two, you are going to get this, okay. Total modes are 3 is there, so 3 into 3 matrix you are going to get, okay. If you multiply this, if you multiply inside, then you add these two matrix, you are going to get Kh, heat due to conduction, is equal to 26.16, 13.08, 01308, okay, 52.33, 13.08, 13.08, 26.11, okay. So after adding, now you calculate the global stiffness matrix, okay. So we have the formula for global stiffness matrix is equal to what, K is equal to Kc plus Kh, okay. So substitute the what you calculated the Kc and substitute the K value. Now just you add here, okay. So 87.92 plus 26 is equal to this, okay, minus 87.13 is equal to minus 74, 0 plus 0 is equal to 0, okay. If you add these two matrix, you are going to get the global stiffness matrix, okay. K is equal to 114, this what, this matrix you are going to get, okay. Now calculate the force vector, okay. So now you calculated the global stiffness matrix, okay. We need the force vector due to convection, okay. Again we have the force due to convection formula is equal to F of H is equal to what, H, okay, that is what, here heat due to convection, ambient temperature, perimeter, length 211, okay. So this is a force due to convection is there, okay. For first element, second element, you have to substitute in the both the matrix, okay. So given data is given in the given data, so just to substitute you are going to get this value, okay. So that is 12285.25, again positive same value here also 2, okay. If you add these two, you are going to get the global force vector is equal to F of H is equal to Fh1 plus Fh2, okay. So you are going to get 3 into 1 into 3 matrix, okay. So this is a global force vector, okay. So after calculating this, again go for the equilibrium condition, okay. How you solved in the previous case, okay. That is equilibrium equation is equal to what, K into T is equal to F, okay. Substitute the global stiffness matrix K value. Here the nodal temperature from the given diagram is T3 is there, T1, T2, T3, okay. So F we calculated, so substitute here, okay. But in the given, now the next, after writing this equilibrium equation, we have to apply the boundary condition, okay. But we know that the T1 is given in this, okay. So already T1 is given 413, just you have to from the second row of the global stiffness matrix, okay, just you from this, okay. So delete this first row, first column, so write down the second one, okay. Minus 74 point this into this, plus 28 into T2 minus T2 into this 33, which is equal to this, okay. So from again we know this T1 value, okay. Just you send this to this side, you are going to get, again substitute T1 value in this, okay. New modify equation you are going to get, that is 228.173 T2 minus, okay, 7483 T3, which is equal to this, okay. After substituting in this equation, if you multiply this means you are going to get 55,479, okay. That is what, 55,479.42, okay. Now replace the second row from equation number 1, okay. So after modification, so you are going to get this, okay. The eliminating the row and column corresponding to the T1, replacing the second row with the equation number 1, so you are going to get this equation, okay. So after replacing this, okay, second row, so you are going to get this 55, okay. So here, okay. So now this is what similar what we did in the previous case, okay. Here we are going to solve on simplification on this two equation, okay. First row first column, second row first column, which is equal to this, okay. If you solve these two means we are going to get temperature is equal to 353.938 Kelvin and T3 is equal to 337.79 Kelvin, okay. So these are the temperature distribution flows inside the thin film, okay. That is a fin, okay. So like this you have to solve that temperature, that is what the problems on fin, okay. So if you want to write T1 value also, you can write here T1 value they given in the, okay. So like that you have to calculate the what the temperature distribution in the fin element, okay. So procedure is same as previous one, okay. Now I will tell just brief how to calculate the this one, okay. So how you are going to calculate, first you need to calculate the this what this heat due to conduction, okay. With the help of this formula you calculate the conduction, that is the first element, second element added, okay. Similarly calculate the heat due to convection, then calculate the nodal force vector, okay, for the both the element, apply the equilibrium condition, okay. So T1 is given temperature here, boundary condition, just to substitute in that, so replace second row. So if you solve it, you are going to get the temperature distribution in the given problem, okay. Like this you have to solve the problems on this fin, okay. So this is very important, okay. So I already told you in the FEM, before solving the problem you have to remember the list of formulae, okay. So I hope you understand this problem. Thank you.